Alright, welcome to the video of the IB Mathematics HL11 checkpoint. This topic is about the trigonometric function and the trigonometric equation. So, let's start off with the first question. Sketch y equals sine of 2x for 0, x is greater than 0 and less than 2 pi. The first thing we should know is that we can look at this problem in multiple ways, but I think because it's the first question, I will look at it as if it's a regular transformation function. So what I'll do is I'm going to first graph the sine of x function. The graph looks like that, and if I label some key points, that's 0, 0, that's pi, 0, and that's 2 pi, 0. 3 pi over 2, comma, negative 1, and that's pi over 2, comma 1. Now, the only transformation that is happening here is that there is a horizontal stretch. There's a horizontal stretch by a factor of 1 over 2. So that means I'm going to multiply all the x coordinates by 1 over 2. So that means if I redraw the graph, my graph will look like something like that. And if I label these points, the 0, 0 is still there. The pi over 2, 1, well, I'm going to multiply pi over 2 by 1 over 2. That's going to be pi over 4, 1. Pi becomes pi over 2, 0. 3 pi over 2 becomes 3 pi over 4, negative 1. 2 pi becomes pi, 0. And then we want to go from 0 to 2 pi. So let's go a bit further. After pi, it's going to be 5 pi over 4, 1, and then 3 pi over 2, 0, and then 7 pi over 4, negative 1, and finally 2 pi, 0. So that's the graph of y equals sine of 2x. So that's my final graph. Let's look at the second question. Solve sine of 2x is equal to 0 for x is greater than or equal to 0 and less than or equal to 2 pi. So I can solve this question immediately because I've already graphed the previous one. But just for the practice, I'm going to look at this in a different perspective of solving as if it's an equation to solve. So how do I solve this equation? Well, the first thing I'm going to do is I'm going to let u be 2x. I'm doing that because I don't like how there's a how the inside of the sign is just not x. So if I rewrite that, it becomes sine of u equal to 0. And in order to solve this equation, well, I think I can solve this using a unit circle here. The sine of u, the sine ratio, tells me the y coordinate on the unit circle. So that means that if sine of u is equal to 0, it means I'm looking for 2 points where the y coordinates are 0, and that's here. So that's going to be 0, 0, and pi, 0. So therefore I conclude that u is equal to 0 and pi, and to write the general solution of this, I can write it as 0 plus 2 pi n and pi plus 2 pi n. Or I can summarize this into a single notation as 0 plus pi n instead, or just pi n is fine too. Now at this point I've solved u, therefore I'm going to replace it back with 2x. And if I solve for x, it becomes pi over 2, pi n over 2. And that's my, well, sorry, that's not my solution. So because I know that x is equal to pi n over 2, I'm going to list out all the answers of x that I know of. I'm going to cut the ones before a 0 and after 2 pi. So if I start with, let's say, negative 1, it's going to go from negative pi over 2 and 0, pi over 2, and pi, and 3 pi over 2, and 2 pi, and 5 pi over 2, and so on. So if I only include the ones before greater than or equal to 0 and less than or equal to 2 pi, crossing those off. So therefore x is equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. This answer matches the solution, the x-intercepts of the graph that I just drew on the left-hand side. I can solve the last question quite similarly. The first thing I'm going to do, as always, is going to let u be x minus pi over 3. And that way I can simplify this equation as 2 sine of u is equal to negative square root of 3. And now solving this equation is a lot simpler. I'm going to first solve for sine of u, and then I'm going to replace u with r. So the r is the reference angle, and I'm going to first solve the reference angle, and when I'm doing that I'm going to change the negative square root 3 over 2 to positive square root 3 over 2. So now if I solve for r, well, sine of r is equal to square root 3 over 2. I can use a special triangle for this case. So opposite is square root 3, hypotenuse is 2, and adjacent must be 1. This is one of the special triangles, and I do know that r is equal to pi over 3 in this case. If I know that r is pi over 3, then I can deduce what the u values will be. Because because sine of u is a negative value, it means that I'm going to be in quadrant 3 and in quadrant 4. In quadrant 3, I know that u is going to be pi plus pi over 3. So let's write it as pi plus r instead. So that's going to be 4 pi over 3. And in quadrant 4, u is equal to 2 pi minus r, and that's going to be 6 pi over 3 minus pi over 3, that's 5 pi over 3. So my final answers are u is equal to 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. This question is asking you for all real numbers solutions, so I'm going to read it as plus 2 pi n. And then I will need to replace u back with x minus pi over 3. So therefore, solving for x, I add pi over 3 on both sides. It's going to be 5 pi over 3 plus 2 pi n. And if I plus pi over 3 on the right hand side, it becomes 6 pi over 3, which is 2 pi plus 2 pi n, or just 2 pi n is fine too. Nothing wrong with writing 2 pi plus 2 pi n or 0 plus 2 pi n. It doesn't matter. There are my solutions. Let's move on to the second row. Find the equation of the graph in terms of cosine of x. So this one is, I'm asking you to find the equation of the graph based on the given hints. So let's try to analyze some hints that I know of. The first thing that I know is that the minimum is at negative 2, 0, and maximum is at 1, 4. So the minimum and maximum gives you a lot of information. First one I can tell is the amplitude. The amplitude is going to be the sum of the two numbers divided by 2. Sum of the two minimum values and the maximum value divided by 2. So that's going to be 0 plus 4 divided by 2, which is 2. So that means that A is going to be 2. We also know that the period. In this case, because the minimum is at negative 2 and maximum is at 1, so I can easily deduce that another minimum will be at 3, 0, and then another maximum will be at 5, 4. So I think it's quite easy to tell the period is going to be 3 minus, sorry, that's hard to read, that's negative 1. The period is 4. So what does the period of 4 tell me? Well, if the original period is 2 pi and I want to do some horizontal stretch, so that the period becomes 4, I think we can use the formula that b is equal to 2 pi over period, which is 2 pi over 4. That's going to be pi over 2. And let's also find the midpoint. The midpoint is the middle of the maximum and minimum, so we can do 4 minus 0 divided by 2, so that's once again 2. So that means that d is equal to 2. And finally, I'm going to find the phase shift. Because I'm asking you for the equation in terms of cosine of x, it's pretty simple. We just need to find one of the maximum points and find the coordinate of that. So phase shift, looking at 1, 4 as the first maximum, so that's going to be c is equal to 1. So using the hints on the graph, we found all the coordinates, all the parameters, so therefore my equation is quite simple. Y is equal to 2 cosine of pi over 2 of x minus 1, close bracket, plus 2. Is going to be my final answer. Question number 5. Solve cosine of 2x plus 0.7 is equal to 0. So the first thing I'm going to do is I'm going to similarly go cosine of, let u be 2x. So that's going to be cosine of u plus 0.7 equals 0. That's cosine of u is equal to negative 0.7. Right off the bat, the moment I see negative 0.7, I know that we will not be able to solve this using the special triangles. So let's go in and do arc cos of 0.7 to find the reference angle, which is approximately 0.795. Because I know that cosine of u is less than 0, this means that we're going to be in quadrant 2 and quadrant 3 using the ASTC, the triangle. So that's going to be it's going to be u is equal to pi minus r, and if I do, I'm going to store this as alpha r. So let's do pi minus r, and it's going to be approximately 2.35. In quadrant 3, it's going to be pi plus r. So let's switch minus to plus, and it's going to be approximately 3.94. So I have two of the solutions here. U is equal to 2.35 plus 2 pi n, and 3.94 plus 2 pi n. And if I want to solve for x instead, I can say that 2x is equal to 2.35 plus 2 pi n. 2x is equal to 3.94 plus 2 pi n. So let's divide it by 2 on both sides. It's going to be 1.17 approximately, plus pi n, and 3.94, 1.97, and because we want the answers between negative 2 pi and 2 pi, that's going to be a lot more of answers of these. So it's going to be a bit of a work. So 1.17 and 1.97, both of these numbers are between 0 and pi. So knowing that, I think I can say that if the n values will be for the negative 2 and negative 1 and 0 and 1. And for all these values, it'll be all the answers. So let's do some series of work. I'm going to store this value as alpha a, and then store the second value as alpha b. So it's going to be alpha a minus 2 pi. So that's x will be equals to approximately negative 5.11. Alpha alpha minus pi is going to be negative 1.97 and 1.17, and then alpha plus pi, alpha plus 4.31 as well. And then same thing for b minus 2 pi, negative 4.31, and then same thing, but b minus pi is negative 1.17, 1.97, and then finally 5.11. Lots of answers. Total there are 8 solutions. Yay. Alright, let's continue on with the 6th question here. Find the equation that models the temperature T in Celsius degrees in terms of hours after midnight T in hours. So the first thing I'm going to do is I'm going to press stat, edit, and then I'm going to type in the numbers here, 8, 12, 17, 23, 8, 9, 10, and 9.5, sorry, 8, 9, and 8, 9, 10, 9.5 should be in the second column. And then this time press stat, but this time go to calculate, and you're going to find the sign regression menu. And right now, if I just plug in the calculate, it's going to give me an error. So I'm going to specify that the 24 hour is 1 period. So forgot to write that here. So 24 hours. And then I'm going to also store this regression equation in y1 just to see the graph of it. And now you'll see on the calculator that A is approximately equal to 1.23, and B is approximately equal to 0.224, C is approximately equal to negative 2.56, and D is approximately equal to 8.85. So my equation is going to be 1.23 sine of 0.224 x minus 2.56 plus 8.85. So that's the equation. And of course you can just try to graph this as well. Make sure you include the stat plot on the graph. I'm going to set my windows to 0 to 24 to show 1 day of period. And then I'm going to go x minimum to 5 and x maximum to 10. I think the graph, the sine graph, looks quite nice along with the points that I have. Moving on to the last row. Sketch the graph of y equals tangent of x minus pi over 3 minus 1. So for this question, I'm going to study some key points that I have here. So first thing is I have a minus pi over 3 here within the tangent. So x minus pi over 3. So this means that my new, I'm doing a phase shift by pi over 3, and it means that all my vertical asymptotes and all my x-intercepts are all going to move by pi over 3. So starting my original, the x-intercepts were 0, pi, and 2 pi on the graph. If I just show you the x-axis, it looks like that. And then my vertical asymptotes used to be x equals pi over 2, x equals 3 pi over 2, but then they all move to the right by pi over 3. So that means that my graph will now have the x-intercepts at pi over 3, and pi plus pi over 3 is 4 pi over 3, 2 pi plus pi over 3 is equal to 7 pi over 3. And also my vertical asymptotes, which used to be x equals pi over 2 plus pi over 3 is going to be 5 pi over 6. 3 pi over 2 plus pi over 3 will be 9 pi over 6, 10 pi over 6. Is it 10 pi over 6? My bad. 11 pi over 6. So if I graph the equation, now it looks like that. Pi over 3. Oh, and also, we need to do the vertical translation by -1. So it means that my used to be x-intercept is now at pi over 3 comma -1, and 4 pi over 3 comma -1, and 7 pi over 3 comma -1. Still have the vertical asymptotes at these points. X equals 5 pi over 6, x equals 11 pi over 6. I guess I didn't really need to draw the 7 pi over 3, but that's okay. And my graph doesn't do anything weird, so if I also include my graph like this, my graph is going to look like that. Now, I have the vertical asymptotes, but now I lost my x-intercepts and the y-intercepts. So first I'm going to find the y-intercept. So let's do some dirty work on the side. My y-intercept is going to be y is equal to tangent of 0 minus pi over 3, or minus 1. That's going to be tangent of negative pi over 3 minus 1. What is tangent of negative pi over 3? If I'm allowed to, I'm going to put the negative pi divided by 3 on the calculator, and that's going to be square root of -3. Is it right? So my y-intercept is now at negative square root 3 minus 1, or somewhere right, 0 comma negative square root 3 minus 1. Now let's also find the x-intercepts. That's going to be 0 is equal to tangent of x minus pi over 3 minus 1. So that's 1 is equal to tangent of x minus pi over 3. So if I replace with u, then r is going to be pi over 4. So that means that the tangent is positive. So it's going to be in the first quadrant, right? So that's going to be u is equal to pi over 4 plus pi n. So that x minus pi over 3 equals pi over 4 plus pi n, which means x equals pi over 4 plus pi over 3 is going to be 3 pi over 12, 4 pi over 12. So that's going to be 7 pi over 12 plus pi n. So I think my first x-intercept is going to be 7 pi over 12, comma 0. And then the second one will be plus pi n, so that's 19 pi over 12, comma 0. I think that's all I have to find for now. So that's my complete graph of y equals tangent of x minus pi over 3 minus 1, including all the key points and the vertical asymptotes. Let's quickly do the last two questions. Solve tangent of pi over 2 of times x plus 3, close bracket, equals 1 over square root 3. So once again, I'm going to say let u be pi over 2 x plus 3. So that's going to be tangent of u is equal to 1 over square root 3. Tangent of r is equal to 1 over square root 3. And I know that r is going to be, if I use the special triangles, opposite is 1, adjacent is square root 3. So that's going to be pi over 6. Because I know that the reference angle is pi over 6, and I know that this is in tangent is greater than 0, which means that we're in quadrant 1 and quadrant 3. So that's going to be u is equal to r here, just pi over 6, and u here is going to be r plus pi over 6, so we're 7 pi over 6. Altogether, for tangent, it's easy because it's always going to be either first quadrant, third quadrant, or second quadrant, fourth quadrant. So u is simply pi over 6 plus pi n, not 2 pi n. And then now let's replace u back with pi over 2 x plus 3. So let's solve for x. X plus 3 is going to be equal to, multiply by 2 over pi on both sides, so it's going to be 1 over 3 plus 2 over pi, so that's going to be plus 2n. X is equal to minus 3 on both sides, so what is that? Minus 8 over 9 plus 2n. Because we're looking for the answers from between 0 and 6, my answers are going to be, oh, my bad, 8 over 3, isn't it? Yes, there you go. So my answers are going to be, well, I think if n is 1, my answer will be negative 2 over 3. So I think we can go n equals 2, and then n equals 3 perhaps, 6, 18, 10 over 3. So I think I can go one more time perhaps. N equals 4, so that's 8, 24 over 3, 16 over 3. Yes, I think that'll be the last one. So my x values are equals to, when n equals 2, that's 4, so that's 12 over 3 plus negative 8 over 3, so that's 4 over 3. And then the next one will be 10 over 3, and then 16 over 3. And that's all my answers, between 0 and 6. Alright, last question. So once again, I'm going to let u be 3x. That's going to be tangent squared of u minus 4 tangent of u plus 3 equals 0. And I think I can easily factor this. This tangent of u minus 3 times tangent of u minus 1 is equal to 0. So that means that tangent of u is equal to 3 and tangent of u is equal to 1. So if I solve for u on each case, tangent of r is equal to 3. Well, 3 looks like a special triangle, but actually it's not. So let's do arctan of 3 to get 1.24, 1.25. And because it's positive, my u is going to be u is equal to 1.25 plus pi n. And that's my answer for that. Same thing on the right hand side. I'm going to replace u with r, and this one is indeed an exact special triangle, so that's pi over 4. That's going to be u is equal to pi over 4 plus pi n. Now let's replace u back with 3x. I think we can say x is approximately equal to 0.416. Not approximately equal to, exactly equal to pi over 12. Right, so that summarizes all the questions on this checkpoint.